All right, in this Math 2, we're going to do 42, 43, 44, and 45 in Chapter 2. There's a couple of different ways I'm trying to figure out how to do this. 45 is pretty self-explanatory, but 43 is a little weird. So, all right, examine the two triangles at the right. Okay, we're examining them. And the question is, are they congruent? I'm going to tell you right now that they are. So you cannot just say, no, they're not, and then just skip out on the rest of the work. So I'm going to show you why they are. So 50 and 60 added together gives you 130. 130 take away from 180 gives you 50, right? And let's see, 50 and 70 added together gives you 120. 120 take away from 180 should give you 60. All right. So when in doubt, you can always figure out what the angles are. Shouldn't be a problem. Now, the one thing you should notice is that the congruent line is in between these same two congruent angles. We have 50, we have 50, and we have 70, and we have 70. So the same purple segment is in between the red and the green angle, and the same purple segment is in between the red and the green angles, right? So this gives us a angle, right? Purple is in the middle between the green and the red. So purple, which is a side, is in the middle between a green and a red angle. So you have side, angle, side, angle, side, angle, angle, side, angle. All right. Now, then you can figure out what the congruent statement is. Just finish this part over here, and then the question is, what sequence of transformations will map one of them into the other? So basically the question is, did you rotate, did you flip, did you translate? So did you rotate, did you reflect, or did you translate? And was it just one, or could it have been a combination of the two? So how did you go from the one on the left to the one on the right? Right, 43 is more than one way to do this. So I'm just going to show you one way. If you figured it out another way and you got the same answer as me, that's great. But one thing that you cannot, there's no way to do unless you figure out what the height is from this part up here all the way down to here. Okay, you have to figure out what this green little portion is. There's no way to do it without that. Now, it shouldn't be that big of a deal. For the base of, I'm going to call it the base of the Christmas tree, the little trunk of the Christmas tree. 4 by 3 is 12. So this, I know for a fact, is 12 units squared just in this area right here, right? There's just a little rectangle piece. Now, this is 4, and this part's right in the middle. So that means this portion down here should be 2, and so should this portion down here. I mean, up there. So the entire part, right, from the corner all the way up to the segment that I want is 2 plus 4, so that gives us a 6. Okay, now this makes it a little bit easier because in this area right here, we have a right triangle. And I know this because calculate the area and perimeter. The dashed line represents it really is a right angle right there. So we have a right triangle, we have a 10, we have a 6, and we want to find this segment out here. So I'm going to call this segment, I don't know, I'll call it T. Okay, for Christmas tree. Okay, all right. Now we have a right triangle with a hypotenuse of being 10. This is your leg. This is going to be your other leg. And we have leg squared plus leg squared equals hypotenuse squared. So we have 6 squared plus t squared equals 10 squared. So we have 36 plus t squared equals 100. So t squared is going to give us, I don't know, whatever 100 minus 36 is. Something with a 4 on the end, I'm sure. 64, there we go. Hey, that makes it really nice, because when we take the square root of both sides, we're going to get t equals 8. So that means the top of the Christmas tree, all the way to when it's touching the trunk, is going to be 8. Okay, well, we're in luck because it is symmetric. So it means this part's also going to be 10. This is going to be 4 over here. That's a 3. That's a 4. This is going to be a 3. So this makes it very easy to calculate at least the perimeter. The perimeter being just the outside of the gray area. So for perimeter, we're just going to add up the outsides. We have, I'm going to start in one corner. So I'm going to start here. We go 10 plus 4 plus 3. So 10 plus 4 plus 3. 10 plus 4 plus 3. 4, 3, 4. Plus 3 plus 4. And then another 10. Or you can just add up one side of it and then double it, because that would be easier. If you didn't realize that, you could do that too. So add those all up and you get your perimeter. We don't have any units on this, so it would be just whatever you get as your answer, units. Now your area is going to be piecemealed slightly together, because you can't just do base times height. This is not going to work. We found the area of the little trunk part down at the bottom, which is 12 units squared, but we need the area of this triangle piece right here. And area of this whole triangle, so the top of the Christmas tree, is going to be the base of it, right? I'm going to do this real quickly. The base of it, the base times the height divided by 2. Well, the base of it is going to be 6 on this side, and then there's another 6 on the other side, right? Because it's 6 from here to here, so it's got to be 6 from here to here. So that gives us a total of 12 as the base. We figured out that the height was 8. Okay, so that's done. Okay, so 8 times 12 divided by 2. So what's 8 times 12? I don't even know. Something with a 9. Okay. 96 divided by 2. So that should give us 48. For the triangular piece. Units squared. Okay, so that's 48 for the triangle piece, and it was 12 units for the area of the rectangular trunk, right? So you need to add those together. So the area of total should be equal to the 48 plus the 12, and that should give you the total area in units squared. Okay, 44. Examine the figure to the right, which is not drawn to scale. Which is longer, A, B, or AB or BC? Examine. Oh, I know what this is. This is a really good problem. Okay, so this goes back to the concept of the smallest side is always across from the smallest angle, and the largest side is always across from the largest angle. It's not drawn to scale, so don't be fooled by anything weird in here. So remember, biggest side across from the biggest angle, smallest side across from the smallest angle. And we kind of need to take this one thing at a time. Now, that's a 90-degree angle. That's a 90-degree angle. Okay, so now we have a conflict, right? Because technically, the AD is supposed to be bigger, and so is DC. So the only question is, which one's bigger than the other? Well, they've got to sort of kind of be bigger than the other two parts in those right triangles, period. So 10 feet is actually describing the length between D and B down over here. All right, so that means if this is 10 feet, that's 68 degrees, that's 90 degrees. This is going to be in this triangle, the one on the right-hand side. This is 90, that's 68, so I got to figure out what the top one is. Top one's going to be 22 degrees. This one right here is 22 degrees. Okay, so that means in the triangle over here, if that's 22 degrees, then that's 68. This is going to be the, oh my goodness, it's kind of hard to do. This side right here is going to be the small side for the triangle on the right-hand side. This is going to be the large side for this triangle right here. Okay, I'm just talking about this triangle on the right. I kind of think I need to cover this up a little bit. Okay, just for this triangle right here. That's the smallest angle, so that's going to be the smallest side. That's the largest angle, 90 degrees, so that's going to be the largest side. 68 degrees is across from this one, so this one's going to be the medium side for this triangle on the right-hand side. Okay, so here we go. Let's see, if that's 90 degrees, okay, for the triangle on the left, this is going to be the large side. Okay, 11 degrees or something else, right? So we got to figure that out. That's 79 degrees. This is 79 degrees. Well, now for this triangle, 79 degrees and 11 degrees. So 79 degrees is going to be across from the medium because 79 is more than 11. And so that tells us for this triangle on the left, 10 is going to be the smallest. So in the triangle on the right-hand side, 10 is the medium side, but for the triangle on the left-hand side, 10 is the smallest side. Okay, so the question was, which is longer, AB or BC? So okay, so let's see if we can do this correctly. 10 is going to be the smallest. This is such a confusing concept. 10 is for the triangle on the right, 10 is the medium. So whatever this side is, it has to be less than 10. Okay, so we know this smallest side has to be less than 10. Because this is the medium, so this small side has to be less than 10. Okay, and then since for the red one, 10 is the smallest one, this side, AB, is the medium one, and it has to be more than 10. Does that make sense? I hope that makes sense. I mean, it makes sense to me, but you kind of have to, like, one puzzle here, one puzzle there, and then just kind of, like, sort of mix them together. So, in answer to the question, AB is actually longer than BC because it has to be more than 10 since it's the medium side. And then that one has to be less than 10 since it's the small side. Okay. Hopefully that explains it, or maybe not. But you still have to write it out. And then the last one is kind of fun, actually. I like these ones more than anything. Let's see. While waiting for the bus after school, Renee programmed her MP3 player to randomly play 2 songs from a playlist at the right. Assume that MP3 player will not play the same song twice. Okay, that's important. A sample space is a list of all possible outcomes for the probabilistic situation. A list of sample space for any 2 combinations of 2 songs. So the first song is A, the first song is B, C, D, and E. So my sample space, I'm going to abbreviate. Okay. So I can have a sample space, and this is what it's supposed to look like. If I play the first song, right, A, right, I can't play the same song again because it said you will now play the same song twice. So that means I have a choice of playing the B song next. All right, well, if I play the A song and then I don't play the B song, I can play the C song. Well, if I play the A song first, I also have the option of the D song, and then I can do the option of E song. All right. But let's say I don't play the A song first. Let's say I play the B song first. So that would look like, okay, if I play the B song first and then the A song second, right? Because I can't have doubles, but I can do A song first, B song second. The order in which she hears the song does not matter for your list. Oh, okay. How can you be sure that you listed all? The order that she hears the song does not matter. So B and A, which I already have here, A and B are kind of the same thing. So if I play A first or B first, as long as I have A and B, okay, well that one doesn't work. Okay, but can I do B and C? B song first, C song second. Yes, because I don't have it yet. All right. Can I do B and D? Okay, that works too. What about B and E? Okay. All right, that works out. Okay, now we go to C song. And then so on and so forth. And you can't play the same song twice, and the order does not matter. So that means I can't do C and A because that's already done, or A and C is up there already. Can I do C and B? No, because I have it over here. B and C I already have. So that means I'm left with C and D, which I don't think I have yet. Okay, and then C and E. All right. So what about D? And then you get the point. You got to do the same thing with D and whatever you have, and then you have to do the same thing with E. Okay, and then whatever you have. So you should end up with not a lot of different possibilities. Okay, you should end up with 5 columns with their stuff, and then count how many you can have possible. All right, are each of the combinations of 2 songs equally likely? Why is that important? Yes, they are equally likely because you don't want to have the A song pop up more often than necessary, because that would ruin your sample space. Okay, calculate the probability that Renee will listen to 2 songs with the name Mama in the title. Okay, well, look at all the ones that you have that have the word Mama in the title. So Mama in the title is A, right? Mama in the title is B. Carefree and Blue, back to Mama in the title, and it would be D. So how many listen to 2 songs that would be with the word Mama in the title? So for example, A and B, that would be one possibility, right? You can do A and B would be one possibility. A B and D would be another possibility. But then you have B and D. What about A and D? That's another possibility. So how many possibilities with 2 songs with the name Mama in the title, right? So how many of them do you have over how many did you come up with altogether? Okay, so total sample space. So what was your total sample space? How many of these things did you find? And then how many combinations have 2 songs that have the word Mama in them? Okay. And then the question is, what is probably at least one song will have the name Mama in the title? Okay, well now you don't need A and B, you just need A, right? So all of these, all of your the ones that we did, A, B, A, C, A, D, A, E, all have the word, at least one of the songs has the word Mama in the title. So you have all of these, you have, well, pretty much all of these, right? C could also, right? Because C and D is one of them, because D has the word Mama in them. And then everyone from D should. And then E, you have to pick and choose which combination, because you can have E and A, or actually you can't have E and A. So you have to figure out how many of them have only one word in the Mama and do the same thing. You have total versus how many you found on top, and it should be a fraction. Does it make sense that the probability in part D is higher than the probability in part C? So I need you to answer that question. I need you to think about it a little critically. Okay? Which one should have more? Okay, part C or part D? All right. I will see you guys later.